All right, young people, let's talk about two-step mole problems. Here's an example. How many grams are there in 7.4 times 10 to the 23rd molecules of AgNO3? Let's take our two different highlighters and find our givens and unknowns. How many, that's my question phrase. The unit that comes after it is my unknown, grams. Are there in 7.4 times 10 to the 23rd? There's the number. Molecules is the unit. And don't forget, we care about the chemical also. Now, it's not telling us to change chemicals. So we're just going to say that grams here must be AgNO3. We'll need that later when we do the molar mass. All right, let's write down our givens and our unknowns for the Guster. Given is 7.4 times 10 to the 23rd molecules. You can write molec, but I wouldn't make it any shorter than that, because mole or MOL, those stand for something else. M, that's mass. You've got to use molec or the word molecules. AgNO3. Take the time to write it out. It's worth it. The unknown here would be grams of AgNO3. Great. Now let's take a look at our mole diagram so that we can plan our strategies for solving this problem. We're starting out with molecules up here. In order to get grams here, we have to first get moles and then get mass. We can't go directly from molecules to mass with one fraction. We're going to have to use two fractions in order to do it. We have to go down to moles first using this relationship. And then we have to go over to mass using this relationship. When we write our relationships for the Guster, we're going to have two chemical relationships, mathematical relationships. The first one is 1 mole AgNO3 equals, and since it's molecules, we're going to use Avogadro's number. That's the magic number that always goes with molecules. 6.02 times 10 to the 23rd molec of AgNO3. The second relationship is 1 mole AgNO3 equals the molar mass. So I better figure out the molar mass off to the side over here. AgNO. There's 1 atom of Ag in AgNO3, so it's 1 times 107.9. 1 atom of nitrogen, that's 1 times 14.0. And there's 3 atoms of oxygen, 3 times 16.0. You add it all up and you get 169.9 grams per mole. So 169.9 grams AgNO3 goes right there. Now that we've written out our relationships, now we can actually do the fractions. Our first fraction is always the given, so we can go ahead and write 7.4. Can you see that? Showing up okay. Times 10 to the 23rd molec AgNO3. And you can put that over 1 if you want to. Times a fraction. Now we're going to need a fraction for each relationship that we have here. So I'm actually going to need to have another fraction there. Go ahead and get rid of that and make some room for myself. I'm going to need 2 fractions plus the 1 for my given. Before I try to figure out what goes on top and what goes on the bottom, I'm going to take the unit and the chemical from the numerator, and I'm going to put it down here to the denominator. Molec AgNO3. Numerator always goes down to the denominator. So that tells me that 6.02 times 10 to the 23rd goes on the bottom because that goes with molecules. That means that 1 mole AgNO3 goes in the numerator. Now we can move on to the next relationship. But before I try to figure out what goes on top and goes on the bottom, I'm going to take the unit in the chemical there, and I'm going to put it down to the denominator for the next fraction. Now I know that 1 mole goes on the bottom this time, and 169.9 grams AgNO3 goes on the top. And when you plug that into your calculator, you should get 208.8 grams AgNO3. Because molecules cancels molecules, this one cancels that one, moles cancels moles, this one cancels that one, and the only thing that you're left is grams and AgNO3. Thanks for watching.